Good day, students. Today we'll discuss about Jackson structured programming in software architecture. To Jackson structured programming concentrate mainly on static and dynamic behavior of the system. So you can take any application. It can be any software or hardware, or it can be any system. We wish to have the architecture. We will focus only on the behaviors. What are the static behavior? What are the dynamic behavior? And how it has been structured in the context of Jackson structured programming. The perspective of this is to find out how the sequential the process are, and in the sequential process, what are the different structured we need to follow. If we have more iterations, it is being represented as an asterisk. If the system is going to have so many options is going to be provided, means that will be represented with a circle, an empty circle marked in the each box. And if it is being in sequence, it is being marked as what? An unmarked boxes. So it is going to provide you the prescriptive form of design transformation in all other systematic design methods. So it is going to incorporate the degree of verification, and it was also practiced with the, and it is also compared with the other methods. So degree of verification is how much input we are giving, how much output is being generated, whether it is being equal, the whether it is being satisfying the condition which is stated in the input condition. Okay, so and the representations are like both static and dynamic behavior of the system. And this is an example of printing the bank statement. So first, to print the bank statement, first we'll be having the print pages. So print pages is it is having more iterations, not iteration in the sense in print pages, it is not only printing the amount, it has been printing with a header, and it has been printing the body and the page summary. So if each and every module is represented, or it has so many things to explain, then we can just have it this with asterisk. So if it is like chapter will be having title, subtitle, and subheadings and all. And so you can have chapters as asterisk. In under chapter, we can have chapter title or chapter heading or something, and some more iterations we can make out of the chapter. So if you can divide the components into sub components, we can make that particular major component as what? Asterisk. So in like print AC account transactions, we can print the date and print detail of transaction and print amount transfer. So like this we can. So amount transfer, we can give more options like how we can pay debit column, we can have credit column, we can have. So and debit column, credit column is an option for the payment which is being incurred there, so that it can be a debit or it can be a credit. So these two are options in which we can provide the amount. So why it has been represented with the same, empty circle in boxes. So the asterisk represents the iterations in which you can divide the component into more subcomponents, and these empty circle boxes are the one where the options is being provided. So like that, we can just frame the Jackson system programming. So there are some rules. As I said before, the sequence is being represented by unmarked boxes, and the selection boxes with a circle, and iterations mean as checkbox, and sequences from what? Left to right. And always there'll not be like the three forms may not be mixed in the sequence. Like it is not like this has to come forward and this has to be come in the next or something like that, or whichever sequencing is followed, and that will be represented. So in Jackson process, you have some 5 major things to get followed. One is first we need to draw the structure diagram, and along with the structure diagram you have to have input and output data stream. Once the input and output data stream has been found, we can merge all those structured data diagram. So first we need to find out, we need to draw the structure diagram of input and output data streams, and we can merge all those things. And we need to find out what are the list of operations that we have for each and every input and output stream. And we need to convert the program into text. And if there is any condition, if there is any iterations in the program, we can add at the end. So first drawing the structure diagram, and I am merging all the components. And we need, if you have any operations that is to be added, you can add. And you just converting the program to text format. And if there is any operations to get being added, you can do the addition process. So the steps can be easily understood with an example like petrol filling station. So petrol filling station example is the manual. It there not be any person who's going to fill up the fuel in the vehicle. There be a person. There not be a person. The customer itself has to fill up the fuel. So it is being started with the pump records team, and every time the customers comes in and fill in the fuel, a record is being generated. So the record is multiple things we have. So it has been given as an asterisk, pump identity, type of fuel. So each and every customer, we need to have the customer has to select the pump, and he has to say which type of fuel that he wants, and followed by the volume. How much volume did he actually need for his vehicle, that he has to put it in the input form. So the record was what record is having multiple iterations. So it is being represented with asterisk. And type of fuel is an option. You can have leaded or you can have unleaded. So meaning, so that is an option. So why this represented with what mean empty circle. So there are 5 steps, right? So first we need to identify the input and output. So for in this example, what are the input that the record has? It has to have the pump identity, type of fuel that the customer is opting for, and volume of the fuel. And the options or whatever you are providing is the unleaded or leaded petrol. Okay, so this is what input, and we found the input, and yeah, just drawn the input and data stream. Okay, so next we are going to create the program structure for it. And how you are going to create it, there are 2 options in which you can produce and you can consume. So the petrol can be consumed by the consumer and produced by the owners. So if you are going to say the particular module is produced or consumed, you need to represent with C and P. So consuming and producing the pump identity, consuming the customer can only consume the data. So it is what in as an input the consumer can consume it. So consumer and consuming and producing the volume of human, and producing the total cost of the transaction. Okay. See here, so if it is record, every time the customer comes in, record has been produced, and it has been consumed. Okay, so like that, we need to find out which one is C and which one is P, and find out that. So next we need to find out the operations. What are the input operations? What are the output operations that we need to have? So like that we can find out and just separate it with what? List of operations. And one more thing is important here. We need to number them. See, 1 is pump identity, 2 is volume, 3 is total cost, and 4 is again pump identity, volume, and 7. So like this it keeps on going. We need to find out what are the order in which that it has to be done. So then we need to move to the text format. So programs has to be, the diagram has to be converted into program. So whichever it has been going on and on for every customer can be put in the loop. So what they are saying, so every time the customer gets in, you will follow the same procedure, right? So that is what given in the loop statements with cases. Okay, so this is all about the Jackson system structured programming, where you can represent the system's behavior, dynamic behavior and the static behavior. What is dynamic and static behavior? Dynamic behavior will be changing, but static will not change. So we need to find out what is what, and we need to frame the structure accordingly. Thank you.